Hello, hello. So we are working on functions. A function is a rule or equation with input values. I abbreviated equation, rule or equation. You really should write both. With input values, that's the domain, the x, and output values, that's the range. So the input, the domain, that's the independent variable. The range is the dependent variable. So you could say that y depends on x. So here's an equation that says that y depends on what we do over here with the x. It depends on what value we plug in for x. So here, if we're given these numbers for the domain, we would just plug in 2 times -1 first, and that kicks out a +1. Bang, that's the first number in the range. Then if we plug in 0, 2 times 0 plus 3 equals 3, second number in the range. And then likewise, lastly, if we stick in a +1, we get a 5 out. So think of it like a machine. When you plug in an x, it's going to spit out a specific y. This is a linear equation, and it's pretty close to being in slope-intercept form, which is something that we're going to be dealing with a lot, which is why I mention it. So if you have these x's, these y's get spit out. Alright, if you're not through writing, you may want to pause and copy all this down. Okay, and so on ordered pairs, the ordered pairs line, that really belongs to the example up top, so we just wrote it in ordered pairs, the domain and the range. So you just match those up. Now let's go and talk about function notation. What we'll start using more of is called function notation. So this f of x, that's how we would say it, f of x, it's the name of a function, and that takes the place of your y. So instead of saying y equal 2x plus 3, as we did up in the above example 1, we would say f of x is equal to 2x. And what that means is this function, as a result of placing in this x, in this case, -2, equals, and we plug it into our equation, it kicks out a 1. Okay, so we would just every single time we plugged in a new x value, we would then write that. So if we plugged in the 0, it would be f of 0 is equal to, plug in 0 for that value, 0 squared minus 3. Okay, that's going to kick out a -3. And then you would just do that for each of the others. F of a +2, well, that's going to kick out a +1 again. That's why it's only written once over here on range. And then when you kick in a 4, f of 4 is equal to 4 squared, that's 16, minus 3, or 13. Right, so that's how we get there. I didn't write every single one of those, but we would just write f of -2, then f of 0, f of 2, and f of 4. Solve each one of those. Alright, example 3. We can say any letter. We can say f of x, g of x, t of x, z of x. We can use any letters of the alphabet just to denote different functions. So f of x above was x squared minus 3. Well, g of x is -2x minus 4. So it's just like having a slightly different name, but the x values are going to be whatever we're given. Sorry, should be pointing right here at the domain. So the first one, g at -4, equals, and I plug in -4 for x. It spits out the answer 4. That goes in my range. G at -1 is equal to, and I plug in -1, where the x is there. It spits out -2, and so forth, on down the rows. Okay, so it's just a different function with a slightly different equation. It could have just as easily been called f of x. So again, we're just kind of organizing the equations and denoting that they're different ones. Okay, here we're just playing a matching game. It's saying, okay, there's some function, h of x, and here's a list of ordered pairs that function has produced. So for h of 6, what is the range? Okay, what is the value? H of 6, we have H of 6 here, it produced a 12. So it's wanting us to say, well, the y is 12 in that case. Then we're going to go ahead and look for H of negative 2. And H of negative 2 produced a 6 with this function. And then H of 8, here's H of 8, we would have gotten a 14 on this one. Alright, so you might want to hit pause again. Okay, you may want to hit pause and copy these down. What we're saying here is, here on number 5, f of negative 2, it's saying, okay, use the equation for the f of x that we see here. That's 2 minus 3x. And so I plugged that in, and this particular f at negative 2, or f of negative 2, produced an 8. Then it's saying on number 6, okay, use the g of x equation. Well, g at 5, and I plugged it in, 2 times 5 squared minus 1, that produced a 49. So it's telling me to look at the proper function and use that equation to get an answer. Alright, you may want to hit pause. Okay, this last number 7 example is just saying, okay, use that function it gave you up above, f of x was 2 minus 3x, and tell me what that equals when I punch in a 4. Alright, so I do the math, I get a negative 10. Then it's saying, okay, take that answer and plug it in, or add it to, what you get with g at negative 1. So you take the function above, 2x squared minus 1, stick that in, negative 1 this time, 2 times negative 1 squared minus 1. That kicks out the number 1. Add those together. It produces the number negative 9. These are just fun and games that we do with algebra. And so I'm trying to show you and introduce you to how those work. Okay? And then this last example, for whatever reason, they threw in one more little continuous function that we wanted to show the domain and range of using less than or equal to, because up here we have a solid dot, less than, because down here we have an empty circle. So here are the domains and ranges for example 8. Okay, I hope all of you have done this at home on the night of the 8th, and you come into class ready and having these finished. Good night.